All right, this video is just to show you how to use Excel to implement a recurrence relation that you've derived from a counting argument. And the problem we're going to use is the problem about finding the number of ways to get a specific sum on a number of dice. This is a problem that comes up a lot in board games and doesn't really yield that easily to our counting formulas, at least not in the general case. So I'm going to use the notation d sub nk. So I'm going to have two different variables as inputs. And the n, it represents the sum that I want the dice to have, and the k represents the number of dice that I'm rolling. So we can fill in some of these because some of them are dumb. So for example, when you only roll one die, you can get 1 through 6 in one way, and you can't get any other number in any other way. So d sub n1, what we've written here, is equal to 1 when the n is 1, 2, 3, 4, 5, 6, because those are the only things you could possibly get. And then d sub n1 is 0 all other times. Similarly, when you roll k dice, if you have 2 dice or 3 dice or 4 dice, you can't get a sum that's higher than 6 times the number of dice. And you can't get a sum that's less than the number of dice. If you roll 2 dice, you can't get a sum of 1, and you can't get a sum of 13. So the d and k is going to be 0 a lot of the time, and it's always only going to be a number within a range that runs from basically from k to 6k. And then if k equals 2, some of these values might be familiar to you. I've listed them down here. K equals 2 means 2 dice. And so this is the sort of thing we were studying with our little grid. When you only roll 2 dice, you can represent it as a 6x6 grid. So there's 36 possible outcomes, and you can count how many of them have each particular sum. And so these are those numbers. And I wrote them down here just so that we'll recognize them when we see them come up in our Excel model. All right, so that's the problem. The recursive argument is actually pretty easy. If you are going to roll a die k times, then that's going to look like the result of the first number followed by a blank. And that blank is going to represent the number of ways that you can get a sum of 1 less using 1 fewer dice. So and that would be the first case. So your dice roll either like, again, to get the sum of the total sum to be n, then your roll either looks like a 1 followed by, this is not the case number, this is actually the first roll. So a first roll of 1 followed by the rest of the rolls adding up to n minus 1. If that happens, if you roll a 1 followed by numbers adding to n minus 1, then altogether those will add up to n. Similarly, if you start with a 2 and then roll numbers that add up to n minus 2, then altogether these numbers will add up to n. And you just do that for each of the cases. So these first numbers aren't the case numbers, they're the first rolls. So you're going to roll either a 1, 2, 3, 4, 5, 6, and you need the remaining rolls to add up to the right thing so that the whole thing adds up to n. The remaining rolls are always k minus 1. If you're going to roll the die k times, then after the first roll, you've got to roll it k minus 1 more times. So we can describe these blanks carefully. The blank represents, in the first case, k minus 1 dice rolls that sum to n minus 1. The reason we say it that way is because we have notation for that. That's exactly what d sub n minus 1 comma k minus 1 means, right? So d sub nk means sum of n, k dice. So whatever you want the sum to be, comma, however many dice you have. So each of these is going to be, we'll be able to refer to it in our notation. So this one, the number of ways to fill in this blank will be d sub n minus 2, k minus 1. This will be the number of ways to fill in this blank will be d sub n minus 3, k minus 1, and so on. So we're always basing it on k minus 1, 1 fewer dice, and then the sum has to be adjusted based on the first number. So these are our cases. And so what that means is that the number of ways to get a sum of n on k dice is equal to the sum of all of these cases. And so this is going to be the recurrence relation that comes from that. So that's exactly one of those things being added on the right-hand side. One of those goes with each of the cases that we just described, and that gives us total number of ways to get a sum of n on k dice. So now that we have that recurrence relation, and also remember we have those kind of dumb observations about the small case values, we can implement this recurrence relation in a spreadsheet and let it do all the calculations for us. It's not strictly necessary if you only have 3 dice and you're trying to figure out how to get a sum of 15. I don't think a spreadsheet is really necessary. You could just do that by hand. But the spreadsheet will allow us to extend this to any sum with any number of dice, and it really just comes from typing in the formula one time and then filling it properly. All right, so here's a spreadsheet. I'm going to walk through the instructions on these slides because it keeps everything in front of us, and then I'm going to move my screen over to a spreadsheet and might show you me entering it into the spreadsheet, so that hopefully that will help if you're not that familiar with spreadsheets. Okay, so the first thing is in my spreadsheet, I'm going to go in, I'm going to make myself some labels so I can read it correctly. I want my N's to be rows and my K's to be columns. And you can see I kind of put something up here that suggests that the N are the rows and the K's are the columns. It seems weird that I would put some negative numbers in here, but that'll be clear in a minute. Putting negative numbers in for the N is not that big a deal because there should just be a lot of zeros. Like if you roll 3 dice, there's 0 ways of getting a sum of -5. It seems like a stupid thing to make a note of, but it definitely is true that there are 0 ways to do that. I don't put negative values in for K because I don't know what that would mean. I don't know what it would mean to roll -2 dice. But I do know that there are 0 ways to roll a sum of -5. So at least it makes sense for the N's to be negative. And you'll see why that's actually helpful here in a minute. And then the main thing is to put in your value. So this is 1 dice, 2 dice, 3 dice, 4 dice across the column labels. And these are the possible sums that I'm talking about. And again, I am including getting a sum of -5 on dice. I'm going to really count that. And I do know that's going to be 0, but let's just go with it. All right. So now I'm going to fill in those values that I know that are the dumb values. And so these are all the values where I'm going to get 0 for sure. I'm going to fill those in. And I'm also going to fill in the values for what happens with 1 die, because I understand that well too. So up here, you see all of my zeros, and obviously those zeros are going to have to be there anytime I'm saying get a sum of a negative answer. There's 0 ways to do that, no matter how many dice you have. The first interesting thing that comes up is, right here. Oops, I can't highlight that. It wants to treat that like a table. That's too bad. I might be able to, hang on. Computer is too clever to figure out that's a table. Can I draw on top of it? No. All right, never mind. Yeah, I can kind of make a little circle here. Hang on, I'll do that. All right. All right, I'm just going to use this circle so that you can see where I'm pointing at. So the term right here, these guys, these are the values 1, because this is in the B column, that's 1 dice, 1 die, and the possible sums there are these numbers. So with 1 die, you can get a sum of 1, 2, 3, 4, 5, or 6, and you can get those in 1 possible way each. You're going to get 0 if you try to have a sum bigger than 6, and you're going to get 0 ways to get a sum smaller than 1 when you're only rolling 1 die. So that's what this column is. So this is the column based on what sums are possible with 1 die. And I've gone ahead and added 0 in as the number for all of these cases where the sum value that I want is smaller than the number of dice that I have. Then there's no way to do that. So I've also added those in. And so the first interesting case is going to be the one right here. And so we're going to focus on the one that goes right there. That'll be the number of ways to roll 2 dice. Right, so number of ways to roll. There's 2 dice and get a sum of 2. So I know that ought to be a 1, right? That should be the number of ways to do that. But I'm going to let the recurrence relation do that for me. So starting at this value, this is in cell C9. Starting in cell C9, oops, I'm going to use my recurrence relation. So here's what that looks like. So putting my cursor in cell C9, I'm going to type the formula. So C9 would be right. It's going to be this. Let me grab it. So C9 is the cell right there. My formula is sitting on top of it, but C9 is that cell. So I put my cursor there, and I'm going to type the formula equals B, and I always start with an equal sign when you're doing a formula in Excel, but equals B8 plus B7 plus B6 plus B5 plus B4 plus B3. So what that is doing is it's going to put the value here. That's the sum of the 6 values that you see highlighted here. So in other words, those are the 6 values that you can get with one die. That's exactly the recurrence relation formula that you see above. So if we were to read the recurrence relation formula using, we use the recurrence relation formula using k equals 2 and n equals 2, so D22, it's going to say D1, D11, D10, D11, D01, D negative 11, D negative 21, right, and so on. So if I read this recurrence relation off with n equals 2 and k equals 2, it's going to refer to the sum of these 6 values. And so when you hit enter, it's just going to tell you that that's 1. So the sum of those things that's highlighted in column B is just 1. And that's correct. That's the number of ways to get a sum of 2 when you roll 2 dice. So that formula is right. And now we can take advantage of the way Excel works by just filling that formula down. And that formula is always going to be summing the relatively, the 6 cells that are related to that relatively. So the 6 cells to the left and shifted up 1. It's always going to be adding those. And that's exactly what the recurrence relation is doing every time. So if I do that, if I select cell C9 and do fill down, and I'll show you on the spreadsheet what that looks like. You fill it down, then you're going to get this column. You're going to get this B column here. And so that's going to go down like that. So every one of those values is being computed exactly that same way. It's adding the 6 values over with one less die, shifted up 1. And you can see that those are the correct number of ways to get those sums. You have 6 ways to get a sum of 7, 5 ways to get a sum of 8, and so on. So those are the ones we're used to from games that use 2 die. And then all you have to do is put your cursor on cell C9 and hit copy, and then paste it over in cell D10, and then fill that down. And then that column will be using the same recurrence. And then you do it again, and starting in cell F11, and then in that column, we'll be using the same recurrence. And so this table gets filled in fairly quickly, and then you can read off. You can fill it down as far as you want and to the right as far as you want, and you will see the number of ways to get any sum with any number of dice. All right, so let me jump over to my spreadsheet, and I'll show you how those, I'll just put those formulas in for you so you can see what it looks like. Let me get this a little bit bigger. That's probably big enough. So here's the starting position that I was talking about, where I've already filled in a bunch of the zeros. And generally I want to have here, it doesn't really matter, but oops. Filling in all the zeros where the sum that you're trying to get is less than the number of dice that you have, then you're definitely going to have zeros. In cell C9, as I said, I'm going to type in the formula, so it's going to be equal, and it'll be B8. So it'll be starting one less die, one less number, and then I'm going to just add the 6 things in a row there. So B5, B4, B3, 1, 2, 3. Oops, skipped 6, number 6. 1, 2, 3, 4, 5, 6. Is that 6 things? Yeah. And so that then is a number of ways to roll a 2 on 2 dice. And if I just grab this bottom right-hand corner, and this is true of Google Sheets as well. If you grab the bottom right-hand corner of your cell that has a formula in it and you pull it down, you will see the formula will sum down. And so you can see this is now the number of ways to get different sums on 2 dice. And then as soon as we get to 13, we're back to 0 again. which is correct. There's no way to get 13 when you roll 2 dice. So now I can just go back to C9. That's the place where my formula was originally. You can actually pick any of these, but I can just copy that. So that's Control C, copy, and then Control V, paste. So I just copy and pasted the formula. You can now check that. I can click up here and see that that is now adding the ones over 1 and the 6 above that, just like it's supposed to. And again, that would be the way of getting a sum of 3 when you roll 3 dice. So 1 is correct for that. And I can fill that down. And now I start to see bigger numbers, but these are all the different ways you can get the sums on 3 dice. And then I can do it one more time if I, oops, no, it's not good. Copy, paste. So with 4 dice, there's one way to get a sum of 4. Oops. And then I can copy that down. And so all that looks good. Any of these, I can grab a whole handful of them and copy them all down if I want to see it go further. Oh, something's wrong there. Oh, that's funny. It decided it anyway, these should all be zeros over here. I don't know. It decided that I must have wanted them to be in order or something. Anyway, so yeah, pay attention to everything's based on this, what happens with 1 die. So as long as those are all zeros, then everything's going to work out over here. But you can see we get such weird questions as, if you want to get a sum of 12, when you roll 4 dice, there's 125 different ways to get a sum of 12 when you roll 4 dice. So these are getting to be big enough numbers where definitely you won't want to have to do it by hand.